In previous video, we have learned about some list functions and how the list is being processed, and also we have learned some functions, that is eval and apply function, in which eval will be used to take unevaluated expressions, and when it is passed to eval, it evaluates those expressions, performing the desired function, and it will be returning the result. So based on the values that is given, it will perform the operation. If it is given some values like symbols, means it will be based on the reference specified environment that is given, it will be returning the value in which the symbol is bounded. When a number or string is being passed, means it will be returning the number or string that is being passed. And if the list is being processed, means it will be checking for the first argument in the list, whether it is of a primitive form. It checks, and this primitive form means whether it includes the lambda construct, if construct, define construct, those construct. If it is given, means eval function, it will be doing the direct implementation. If any other user defined any other functions apart from these primitive forms, if it is used, means eval, it will be calling recursively on each elements, and then it will be calling a function called as apply, in which it will be passing the arguments, value of the first element, which will be a function. And apply also, it will in this apply case, what it does, it will be processing if it is not a primitive function, means it will be performing the function on those values, getting some result, and will be returning that value to the eval function, and this value will be given for the display. So this is the process that is being done when primitive functions is not being used. So next is like we are coming across the equality and identity constructs, in which three primitives are used: equal, eqv and eq. So here eq will be doing a pointer conversion, and it returns true if its arguments, they are literally referring to the same objects. Okay, so eq, it relates to some pointer comparison, and returns the true value if it refers to the same object in memory. So two symbols that look the same are eq. Two variables that refer to the same object are eq, which means they will be returning the true value. So eqv, it is like eq. It returns true if its arguments are eq, or if its arguments are numbers that have the same value. So same value, if it has, means eqv will be returning the result as true. So in eqv, it does not convert integers to floats when comparing integers and floats though. So it won't, in case it should be either both the values should be integers or it should be float. Integer and float, it will, if it is given, means it will be returning as false. Equal, third one, equal, it returns true if its arguments, they have the same structure. It follows the same structure. Two objects that are eq are both eqv and equal. Two objects that are eqv are equal but not necessarily eq. Two objects that are equal, they are not necessarily eqv or eq. So these are some concepts based on this eq, eqv and equal. So you can compare these three like this. Eq is sometimes called an identity comparison, and equal is called an equality comparison. So some examples you can see, like define clam 1, 2, 3. So here 1, 2, 3, it is considered to be as a list. Define octopus clam. So these two point to the same list. So eq clam, like that, if it is given, means it will be returning true. Why? It refers to the same object. Similar is the case here also. Clam and octopus. It returns a true value since it points to the same object that is stored in the memory. EQ, if this is the case, means it will be implementation dependent. So it will be returning sometimes false because it may not be pointing to the same object in the memory. Similar is the case here, 10, 10. So sometimes it will be returning true because it is implementation dependent. Then EQV 10, 10 means it will be always, it returns the value as true because it should, in case of EQV, it will be referring to the values of the terms. Okay, values it will be constrained. In case of EQ, it will be relating to the object that is stored in memory. Pointer comparison will be done. So EQV 10.0, 10.0, it will be returning true. But in this case, EQV 10.0 and 10, in that case, it will be returning the value as false. And if equal, if it is used, clam and 1, 2, 3. So both of them, they are considered to be as the list structure it is using. Okay, so this is also a list. Clam is also, it is treated to be as the list. In this case, it will be returning the value as true. Here, equal 1, 2, 3, 1, 2, 3, both of them are list. So this returns the value as true. Okay, so EQ, it will be considering the pointer comparison, EQV, the value, and equal, it will be comparing the structure. Then to search for the elements in the list, in order to search the elements in the list, it makes use of two set of functions. Like one set of function is member, MEMV and MEMQ. These three forms one set of function in which it takes an element and it will be taking an element that is Z and it will be taking a list as arguments. Okay, so for example, if you consider here MEMQ, so this Z will be searched in this list. So Z is the element and this is the list. So once Z is found, from that location towards the end of the list, what all are the elements, those will be returned. Okay, so it will be returning the longest suffix of the list beginning with the element. So when Z is found in the list, from that list towards the end of the list, the elements will be displayed or stored. Then MEMV means, in this case, it will be making use of the EQV. Here EQ it made use of, and here it will be MEMV, it will be making use of EQV constructor. So when Z is found over here, it will be returning the longest suffix. So in this case, what happens? It is searching for an element Z, and the list that is given is XY. So here Z is given like this within bracket Z. So this is some other sublist. We can treat it as a sublist, and W another element. These are elements, and this is some another sublist. Why? Because it is given inside the parenthesis. Okay, so if it is found, it will be returning the value as true, and that will be returned. So here, since this element is given and in the list it is given as some list format, it will be returning the value as false. Okay, then member is Z if it is given in the form of list. Then inside this list, it will be checking for the list which is found over here. So it will be returning the value as ZW. That is the longest suffix. So in this case, it will be checking for the construct equals. Okay. So if the search function member is used, it will be using the construct equal to identify the statement, to identify the elements. So this is the difference between these three functions. MEMQ, it makes use of EQ, MEMV, EQV, and member, it makes use of equal for comparison. So if the element is not found, it will be returning the value as false. So another set of function in order to search is ASSQ, ASSV, and ASSOC. Search for the values in the association list. So association list or A list, it will be having a list of pairs. So it is dictionary implemented. Okay, it is in the form of a dictionary which is implemented in the form of implemented as a list of pairs. The first element of each pair will be considered as key, and the second element is the information corresponding to that key. So ASSQ, ASSV, and ASSOC, it will be taking a key and the A list as argument, that is the association list as the argument. What it returns? It returns the first pair in the list if there is one, whose first element is equivalent to the or it will be comparing these operations EQ, EQV, and equal with respect to the key. Okay, so it will be returning the first pair in the list if there is one. What does it compare? It compare with the key that is given as an argument with these construct EQ, EQV, or equal. So if a search is done based on ASSQ means it make use of the construct EQ. ASSV means it make use of construct EQV, and in case of ASSOC it makes use of equal. If there is no such pair that is found, then it will be returning the false. Okay, so in association list we'll be having some list of pairs, key, and some information corresponding to that key. Functions that is used is ASSQ, ASSV, and ASSOC. It compares this with the it will be comparing the key with the association list, making use of EQ, EQV, and equal for comparison. Next is related to the strictness and lazy evaluation, in which there are two strategies, strict evaluation and non-strict evaluation. Lazy evaluation comes under non-strict strategy, in which argument will be evaluated only when the arguments are needed. And in case of strict evaluation, the function will be evaluated after its arguments have been evaluated. So we can see that with an example. So there are two components of evaluation, that is applicative order evaluation and normal order evaluation. Applicative order evaluation means it will be evaluating the function arguments before passing them to the function. Normal order evaluation, it will pass the arguments unevaluated to the function. And lazy evaluation, it will be following the normal order evaluation. Scheme will be using applicative order in most of the cases. So we can consider here the example. This is a function that is defined, double. So if it is given it like this, double star 3, 4, and it makes use of applicative order means first evaluation will be done, that is 12, and then it will be given as arguments to the function. Okay, so evaluation will be done for the star 3, 4, and then it is given as argument to the function double. In case of normal order evaluation, this evaluation is not being done. This will be considered as a single parameter, and this parameter will be given as argument to the function double without evaluation. So here what it is, star 3, 4, it is given as argument and without evaluation. Then it will be evaluated separately to get the result. So difference is, comparing both these two, difference is like normal order, it will be multiplying the arguments twice. That's the main difference. And in applicative order, it will be multiplying only once. So this is the difference between normal order evaluation and applicative order evaluation.